Okay, so Vy is equal to 25 times 10 to the power 3 Newton. Okay. Ixx equal to, so I'm going to refer to the table. Ixx is equal to 40.8 times 10 to the power 6 minus 6. And then we have our thickness is equal to, so thickness of the web, so thickness of the web is 7.24. Okay. So if I could write down the information of our BF. Okay, so BF, I do apologize for jumping here and there. Okay, so BF is 166, D is 205. 166, 205, and TF is equal to the thickness of the flange, 11.8. Okay. So now we want to find the first moment of area about the x-axis. So this is equal to width multiplied by depth multiplied by y bar, right? Because of the area of the first moment of area is about the x-axis. This direction over here will be your width, and this direction over here will be your depth. Okay, so it's very, very easy to make mistake over here. Okay, you have to be really, really careful. So this, I'm going to take it as the first moment of area for the flange plus by the first moment of area of the web. So I'm going to divide it this way. Okay, that's my division line. So this is what I address as my flange, and then this is where we describe it as the web. Okay, so this will be equal to the width, 166, the depth, 11.8. I'm going to do in millimeters. Okay, and then the y bar is 205 divided by 2 minus by 11.8 divided by 2. I'm very sure it's 11.8 divided by 2 because the thing that compensate over here, the offset, is always the depth. Okay, that's why I always grill you into width multiplied by depth. Okay, not depth multiplied by width for this reason. Okay. Yep. So this will be plus. So the width of the web is 7.24. The depth will be 205 divided by 2 minus by 11.8. Okay. So why that's the case? Because the thickness from here to here is 205 divided by 2 minus by 11.8. And then the y bar for this case is 205 divided by 2 minus by 11.8 and then multiply. So 205 divided by 2 minus 11.8 divided by 2 times by 11.8 times by 166 is equal to 189.22 times 10 to the power 3. I'll do it again. 205 divided by 2 minus 11.8 divided by 2 times by 11.8 times by 166. 189.22 plus by 205 divided by 2 minus 11.8 equal square the whole thing times by 0.5 times by 7.24 is equal to 29.780 times 10 to the power 3. Let me do it again. squared 0.5 times by 7.24. Yep. So this will be equal to 189.22 power 3 plus 29.78 power 3 is 219 times 10 to the power 3 millimeter cube, or 219 times 10 to the power minus 6 meter cube. Okay. I don't know whether is it right or wrong. Let me check. Yep. Okay. So finally, once that is known, you can find your shear ZY at point B is equal to 25 times 10 to the power 3, 219 times 10 to the power minus 6, divided by the I 40.8 times 10 to the power minus 6, and the thickness will be 7.24 times 10 to the power minus 3. So it'll be 25 power 3 times 219 power minus 6 divided by 40.8 power minus 6 divided by 7.24 power minus 3. It's equal to 18.535 times 10 to the power 6 Pascal. Okay. So now we have to draw the element. So let me copy the entire structure. First, I do apologize. Hold on. I'll come back. Okay. So we're going to draw the element at point B. So I'm going to sketch the element. So for this term test, you need to be able to sketch the element. Okay. So this is our element. This will be our X. This will be our Y. And this will be our Z. Okay. And then we know that our Z, we calculated our Z is equal to compression. Is it compression or tensile? I can't remember now. Sorry. So it's compression 14.948. Okay. So we have compression 14.948 times 10 to the power 6 Pascal. And the shear stress will follow the shear flow. Can you see this arrow? I will make it clearer. That arrow is going in this direction, yes or no? Right? So you follow the direction. Okay. So this will be equal to 18.535 times 10 to the power 6 Pascal. I do apologize. I should move this lower. Okay. So when hold on, there's a question. I was wondering if you could show the shaded area we took for Q. I just trying to visualize. Okay, so the shaded area, I will do this again. Okay, that was a question online regarding the area. Come on, Eugene, seriously. Okay, so someone online asked about the first moment of area. The first moment of area I'm taking. So this is for the flange, and this, can you see the shading in blue, yes or no? You can see, right? Or maybe I do hatching. This is the wet. Okay. Jihan, is that okay? think he's okay. I hope he's okay. But anyway, yes, he's okay. Right. So, as I said, when I was a young engineer, right, I always thought shear stress is very insignificant, okay? So this is quite significant over here. We have a shear stress higher than our what? Normal stress, okay? So the advantage of knowing your shear stress is you can use a smaller factor of safety, right? There are engineering work going out there where they did not take into considering the shear stress. They just calculate the normal stress, and then they multiply by a factor of safety of 3, for example. Right? The structure will still be sound, don't get me wrong, right? But you might over-design. And for mechanical engineers, over-design is never an option. Any idea why? For mechanical engineer, over-design is never an option. Because we are the people that design things that fly. We are the one that design things that move, yes or no? We don't design pyramids, do we? Right? Pyramid ever move? No. Okay. So for mechanical engineers, I've been asked by my friends in civil engineering, why do you need to know things so much in detail? Because in civil engineering world, how do you know the mechanical properties of soil, right? All our structures are resting on soil, yes or no? Right? So when they are unsure, when the weather is so bad, when it rains, the soil soak up the water, right? The mechanical property changes. So for civil engineers that build structure, it is okay to use a safety factor of 8, right? For them, it's fine. For us, no go, man. Okay? Why we design things that move? If we're going to design a building, go for it. Follow what they are doing, okay? But we can't do that, okay? I have a question. Yes.
I was just going to ask, like about the shear ZY and shear YZ. Like, I understand that it's shear ZY because it's intersecting that plane and acting in that axis and everything. But why is it that you on that sketch you draw it in those corners rather than like the other corners?
Yeah, this is because if you view it from the I'm doing it because of convenience. Okay, so when we look at when we look this way, Y and Z, right? It looks like this.
Oh, okay, I see. Yeah, that makes sense.
Okay, it looks like this. Okay, because the shear stress will never point towards the same direction on different planes. Okay, that is the only reason. So if you look at shearing stress, I think we did this in, I can't remember now. If we did this in, what's it called, a while ago. Where, yeah, if you look at here, right? Was it this lecture? Let me go on. So I draw a figure that is so small, probably, my apologies, I drew over here. Yeah, this one, okay? Right? So the shear stress will never act in the same direction or from one plane to the other, okay? This is week 3 Friday. Good question though. Right, so we are going to, now are you want to, okay, let me do another problem. If I cannot finish, okay, I'll still do the homework question. Or you want me to do the homework question now? Anyone? Homework question on thin wall? Because some test is getting nearer. Okay, I'll do the homework question. Then I'll do another example on Wednesday. Okay, so let's do the homework question. Let's look at this question over here. Hold on. Right, so I want you all to see this question. And as I said, this is done by the publisher, not me, okay? And we see that Y Do they take the web? Yes or no? Right? If the shear force is coming down from the top, right? And we have 2.5 times 10 to the power 3 pounds, right? So what is going on? Yes or no? You're like, Eugene, what you are teaching, is it valid or not? Okay. So if you look at this problem, right? They took the web, right? They took the web to identify the first moment of area, right? This is a wrong approach, by the way. Okay, I'll tell you that. This is a wrong approach. Okay. Wrong or different, hard to say. Okay. For me, okay, I don't want to discredit the book. Okay, it's a different approach. What approach